Now, let's talk about that problem that you voted off the island. It's that problem right there. Only instead of a box, you've got a car. That car is going at 20 kilometers per hour. That's 12 miles an hour. You're not going to get to Denver anytime soon. That's slow. And we're told that you're on a level road. You slam on the brakes so that it locks the wheels. And you slide. And you slide a distance of 10 meters. Well, then we're asked, what if that car were going 4 times faster, 80 kilometers per hour? And what if it was the same car on the same road and we slammed the wheel or slammed the brakes? How far would it slide? Now, this problem got voted off the island because you didn't have much information. You didn't get the mass of the car, you didn't get the coefficient of kinetic friction of the road. Man, it seemed like someone wasn't doing their job. But I promise you that everything you need is right there in that problem. Let me show you how to do this. It's the same problem. I'm going to start the same place. My initial energy before we slam the brakes is kinetic. 1/2 m v initial squared. My final energy after I come to a halt is 0. And those are not the same because there's friction done. This is by the road, on the car, over a distance. And it's negative there because the friction's acting opposite the motion. Now, I don't know what the mass is, but I know it's the same whether the car's going fast or slow. I don't know what the friction between the road and the car is, but I know it's the same car on the same road. So it's the same friction. Friction doesn't depend on how fast you're sliding, just on the normal force and the coefficient of kinetic friction. It's the same. Now, is it going to hurt your feelings if I rewrite this v squared as v initial times v initial? That's still the same, right? If that second slide, the car is going 4 times faster, this gets 4 times bigger. But so does this. And that means that the positive part of this equation gets 16 times bigger. Now, if this equation is still going to add up to 0, with the positive part of it getting 16 times bigger, then the negative part has to get 16 times bigger. And if the friction is staying the same, that means that this delta x has to get 16 times bigger. What that means is that delta x for the fast car is going to be 16 times delta x for the slow car, or 160 meters. Now, some of you may have gotten that answer and rejected it as silly. That's a football field and a half. You slam on your brakes and you slide for a football field and a half? That's ridiculous. Well, it's not very physical because the first assumption wasn't very physical. If you're only going 12 miles an hour and you completely lock your brakes and slide for a whole 10 meters, you're on the slipperiest ice we've ever seen. That is Havre, Montana in December. Okay? That is one slippery road. Now, here's another thing. that makes this a little bit unrealistic is that when you hit your brakes, you hear a machine gun going off. At least I hope you do. If you hear a machine gun going off when you hit your brakes on a slippery road, that means your parents love you. Okay? Because that's the anti-lock brake system. What that anti-lock brake system does is that the calipers grab the disc to stop the car. As soon as it senses that the car's about to slip, it lets go. And then it grabs again. And as soon as it feels like it's going to slip, it lets go. And that's what the rat-a-tat-a-tat-a-tat-a-tat, that's your calipers going in and out and in and out and in and out. If when you hit the brakes, all you hear is a scraping of the tires against the road, you need to have a heart-to-heart talk with your parents. It should start, why don't you love me? What have I done? What have I done? Okay? Get them to get you a new car. Now, you know that when you took that driver's exam to get your license, the hardest part of the written exam was how far are you going to slide? And there was a table that you had to memorize, and it was very complex. Now, the physics would suggest that, hey, you're going twice as fast, you're going to slide twice as far. Did I say that? I did not. You're going to say I said that, but I'll call you liars. If you're going twice as fast, you'll slide 4 times as far. That's what I meant to say. Okay? Because you'll have 4 times the energy. But the table that you had to memorize was more complicated than that. And that's because here we're assuming that as soon as you see that elk, you've hit that brake. But in the driver's test, they assume that, oh, you see the elk, and then you do, oh my goodness, an elk. And then you hit the brake. They take into account that, oh my goodness time, which is independent of velocity. So, questions on this problem? I solved it using a technique called proportional reasoning. It is one of the most important skills to have as a human being. Unfortunately, it's one of the skills that we often do not teach in schools. I think that's a mistake. The ability to say, hey, if this changes by 2, this changes by 4. If you're going to be a future science teacher, I would beg you to teach your students that skill. Okay.